So before we start taking the signal from the camshaft position sensor and crankshaft position sensor, so I have connected the scope lead channel 1 to pin 1 and the ground lead of the scope or black lead to pin number 2. So I am going to give you a hint how the crankshaft and camshaft position sensor with 3 wires on this type of vehicle work. So this is the hub, either on the camshaft sprocket or behind the camshaft sprocket. This is the hub located on the camshaft, or either that's if that's the long big ring around the flywheel. So here, as you can see, signal voltage 5 volt or 0 volt. So why it's 5 or 0? So the reason is this: as this reluctor or hub is, this area is close to the sensor, so this space here, this gap, air gap, has decreased, and so the magnetic field is strengthening inside the sensor, and that switches the sensor on. So as soon as the sensor switches on, the voltage will have become here 0. So when this hub is rotating, so this hub is rotating, so as soon as this slot approaches and it has become straight away opposite the sensor, so the air gap here and between the sensor is increasing, so the magnetic field strength is also decreasing, so the sensor is no longer switching, so the voltage will stay here at 5 volt. So when the voltage is 5 volt, so when the voltage is 5 volt, it is going to act like this. So this is the line, this is the Y, and this is the X. So voltage 5 is going to be here, then this is the period, and when it has become 0, it will drop here 0, and then 5 again here, then drop 0 again here. So as soon as the voltage threshold just drops from 5 volt, and it's going to show in the lab scope as 0. So then again here 5 volt, then 0, 5 volt, then 0. So how that's the theory, that how the sensor, camshaft position sensor and crankshaft position sensor on this vehicle work. So the crankshaft position sensor is working or works in the same way. So there will be many slots here like this, blah blah, and there will be one bigger slot or one big teeth like this. So which engine recognize engine how to say, so that is going to be for the ECU as a reference, so that can recognize the crankshaft position, that in which position is that. Either that could be slot, a big slot, or a big teeth like this. So when the gap, the air gap between the sensor and here, the notch or the teeth is increasing, the magnetic field is strengthened, and that switches the crankshaft or camshaft position sensor on, and the voltage has become 0 here. When that gap increases, so the magnetic field is also, the strength of the magnetic field is also weakening, and that decreases the magnetic field. So this sensor is no longer switched on, so the voltage here is going to be 5 volt. So I have set up the lap scope, so the time base is here, 50 millisecond, the whole from here to here, and the voltage is 10 volts. So now I'm going to crank the engine and you watch. So fortunately we have got both crankshaft and camshaft position sensor signal. So let me zoom that out. So this is the reference point. Let me do that a little bit more, and so as you can see, I am pretty sure the timing will be out, because in any case that shouldn't be like this. This or this should align to this point or this point of the camshaft position sensor somewhere, but I haven't got a good known correlation camshaft and crankshaft position sensors signal. So I'm going to check the timing visually, and if the timing was out, and I will show you that how far it's out, so how many degrees it's retarded or advanced. So then when in case the timing is out, I'm going to reset the timing and take and retake the camshaft and crankshaft position sensor correlation signal. So keep in mind, this is where we have got camshaft and crankshaft position sensor correlation signal before checking the timing alignment. So let me zoom out a bit. See, this is one revolution of the flywheel, 2 revolution of the flywheel, as you can see here as well. So from here to here, 360, and from here to here 720 degrees. So I'm not sure whether this is out or not, because see here, I think that will be out, because that one of the drop line should match this side or this side, either this or this or this. I'm not sure, because I haven't got any good known signal for it. So I'm going to check the timing alignment visually. So to check the timing alignment visually, I'm going to remove the right hand tire or wheel, and then the splash guard, then remove the auxiliary belt, then need to support the engine from bottom, and then I'm going to remove the engine mounting, then I'm going to remove the crankshaft pulley, then I'm going to remove the timing belt cover, upper cover if it had a lower cover. I'm going to remove that one as well. So when I remove, and I bring that picture to you as well, whether the timing is out or it isn't. Okay, as you can see, these are the teeth. So 2 are close together as you saw on the signal, and 3 are something about, maybe, I'm not sure that how many degrees between them that they are located to each other. So when this teeth approaches this sensor, so that strengthens the magnetic field, so the sensor switches on, and the voltage at signal voltage has become 0. So then this is the empty space between these two. So when there is no teeth, this teeth between the sensor, when there is no this teeth close to the sensor, so the voltage at signal wire remains 5 volt. So as soon as this teeth approaches this sensor and has become close or aligned straight with the straight line to the sensor, so that the magnetic field has strengthened, and it switches the sensor, and the voltage at the signal wire has become 0, because the transistor inside of the sensor is switches, so the voltage has become 0. So these are the 1, 2, 3, 5, 6 teeth. And also I have checked the timing alignment, so the timing is aligned, and there is, if I am able to show you, just give me 1 second. So if you can see this mark here, this mark is aligned with this one. I'm not sure if you can see. Let me show you from the top. So this notch is aligned with this teeth here, with this knob. So the timing belt is all right. So this groove is straight aligned with this knob here, just small knob here. And also this is the alignment, because this is aligned there. This hole is at 8 o'clock and the bolt is very loose, can be tightening, so there is no any force. So because the both hole, the camshaft sprocket hole aligned with the hole on the head, so there is no problem with the timing alignment. So I'm going to put everything back and go for the injector signature testing. Go for the injector signature signal testing. So see that which injector is firing and which is not firing. So now I have come to check the injectors. So this is the injector description. As you can see, injector signature test. So control wire 1 test at harness connector component connected, back proving. So use scope setting provided, connect scope, yellow channel to pin 1, black channel to ground. So this time yellow channel is going to be the power supply, so we are going to check the power supply through the pin 1 or wire which is supplied from the ECU to the injector at pin 1. So condition, engine idling, expected result, waveform should be as image provided, frequency should increase with the engine speed. So voltage should range from 90 volt to 0 volt approximately. So this is wire 1 we tested. Now we are going for wire 2. So the second wire which is connected to the injector. So control wire 2 or pin 2 at the injector connector. So test at harness connector component connected, back proven. Oops. So control wire 2 test at harness connector component connected, back proving. So use scope meter, use scope setting provided. So connect scope yellow channel to pin 2. This time the wire 2 or pin 2 at the injector connector is going to be the power supplier. So black channel to ground, condition, engine idling, expected result, waveform should be as image provided, frequency should increase with the engine speed, voltage should range from 90 volt to 0 volt approximately, possible cause of unexpected result, bad connection, broken cable, blown fuse, bad this is an example. This is generally information is given because this injector hasn't got any fuse in the circuit series. So this injector are straight away supplied from the ECU and back to the ECU. So there is no any external power from the battery involved. So both channel is either power for the injector and ground for the injector. So once one wire is power to the injector, the other wire has become ground for the injector, and once the second wire is power for the injector, the first one has become ground for the injector, and the waveform should be like this. So when you're measuring the injector voltage, so connect the channel 1 of the scope to one of this two, for example connector 1, and the other lead of the scope should be on the battery negative terminal or post. So here both concepts are used by the ECU. So high drive and high side drive and low side drives. So when one wire is driven by the ECU as a high side drive, so the other side has become low side drive, which grounds through the ECU by the ECU. And then when the other wire is high side drive and the ECU omits voltage to the injector, this side has become low side drive, this side has become the ground, has provide the ground part for the injector. So both concepts are used. So this each injector wires can be ground or can be live or power wire. So when you're measuring the voltage on the scope meter, so the voltage can reach from 0 to 90 volt. So when you connect the scope meter channel 1, first connect to pen, either pen number 1 and 2, and the other lead of the scope meter should be on the battery negative post or terminal. Then swap this channel, the yellow channel, and connect to pen 2 of the injector, for example, and the other should be on the other lead of the injector, the scope lead, sorry, should be on the battery negative post. So you will have on the scope meter screen same wave pattern as for this one. So once the injector one wire is high side driven by the injector high side drive, so the power is emitted by the ECU, and the other wire provides the ground part for the injector. So next time the power is emitted by the injector through the negative or ground wire of the injector, and the one which was previously power supplier, so the ground can be provided from the for the injector through this wire. So either wire can be power supplier or a ground provider for the injector. So 100 volts 5 millisecond, so 100 volts the X, the Y longitude or amplitude, and the horizontal distance is 5 millisecond. So I'm going to crank the engine. So this is the current ramp signal pattern. So as they say, pre-injection current draw should peak approximately 13 amps. So that's going to be 13 amps by here to the peak point. So main injection current draw should peak approximately 13 amps. So this is going to be 13 amps again. The main injection current or main injection event current should peak to 13 amps. Then the duration, which is this area and this period, should be approximately 8 amps. So that should be 8 amps by here. And also this duration is half of so pre-current or pilot injection current period should be 0.5 millisecond, and the other should reach the main injecting current draw or injection current period should be approximately 1 millisecond. So this is the sine wave or the wave pattern for the current ramp test. Let me show how to do. So current ramp test. So this is the wave pattern for the current ramp test. The meter setting. So I'm going to be that little bit. So the setting is 20 amp per 5 milliseconds the duration. So going to connect this inductive pickup clamp and select the low amp, which is 20 amp, and that is going to give us 100 millivolt equals 1 amp. So I have connected the clamp meter around the injector. So let me show you if you are able to see. Oops. That's the clamp pickup, inductive pickup clamp that I have connected around the injector. Okay, now I'm going to crank the engine. That's the current ramp of the injector, which has been just changed. So now I'm going for the next injector. So I have connected the clamp, inductive pickup clamp meter around the other injector wires, and now I'm going to crank the engine. So now I'm going to check each injector resistance, that how much is the resistance of each injector. So the car is completely cold. It has not been tried to start, or the engine hasn't been tried to be cranked. So I'm going to take every injector resistance value. So injector number 1 value, so it's 1.5 ohm, which is very close to the specification. So it's approximately 0.9 injector 1 resistance value, and injector number 2, so injector number 2 is over limit and it's completely need. So this one is 1.3. So 1.3, it's okay, not that much bad, but let's check this number 3. Number 3 is 1.2. I'm not sure whether you are able to see or not. So so it's 0.9. That's number 3, and number 4 resistance is also 0.67, which is okay. It's 0.4, 0.3 right now. Resistance is also okay. Okay, now I'm going to check the glow plug. I think that could be the problem. So this is glow plug number 1. So the resistance is 7.3 ohms. This is glow plug number 2. 123.4 kilo ohms. So this was number 2. 123.4 kilo ohms, and this is number 3, 142.1 kilo ohms, and this is going to be number 4. So 4. Four is 57.3. So all 3 glow plugs are faulty. I'm going to replace that. In spite of that, I had all the time glow plug control module feedback circuit fault, but my attention was not that much that it's going to cause that much problem that the engine is not starting. So now I'm going to replace 3 glow plugs and then try again starting the engine. So once again, number 1 glow plug has 10.7 ohms. 2 has 124.3 kilo ohms. So 3 has 143.1 kilo ohms. So 4 has 58.2 ohms. So which should be replaced, that one as well. So I'm going to replace 3 glow plugs and then see if we can start the engine, this bloody engine. So I have put cable tie around the glow plug, and I pull that up. I keep pulling that up while turning the glow plug, while anti-clockwise, while turning the glow plug anti-clockwise like this. So new glow plug, check the resistance. Room temperature is about garage inside environment temperature is about 14 degrees of Celsius, and this is the new glow plug resistance, it's 0.7. So I was able to remove these two glow plugs, but this one, the third one, is also faulty, but I didn't take too much risk, because the risk was that the glow plug may be broken, so then I cannot compensate that. So the first one is all right, it's working, it's 1.5 ohms of resistance, and the second one is no good. The third one I have removed, the fourth one I have removed. I'm going to replace that, and then try start the engine. So the second and the second and one remains not changed. So I'm going to just crank to clear the whole of the glow plug little bit. Because I have put too much carburetor cleaner, WD-40, some oil around the glow plug when I was removing, because that was too tight. So this fluid has gone through the whole of the glow plug. So I'm going to do a few more revolutions of the engine, so to clear that out. So now it should be all right. I'm going to install the new glow plug. The new glow plug tightening torque specification is 14 Newton meters. So 14 Newton meter. So 14 Newton meter. Okay, now I'm going to put the third one from the first cylinder. So 1, 2, 3. So I'll install the fourth one. So now I'm going to connect everything back together and then try to start the engine if it's started. So I have connected everything back together. I have replaced two glow plugs. The second and one have remained as old glow plug. I didn't change that because they were too tight as siezed. So the risk of the braking was possible. So I'll put everything together. Now I'm going to crank the engine, see if the engine starts. still no chance the engine to get started.